Okay, we're going to be looking at the Unit 2 practice test or the Unit 2 review for the Unit 2 exam. Okay, so if you have not pulled this up and printed it or started working on it, you might consider that. All right, the first thing we're looking at here is it says determine the correct operation for the rules, and you've seen this on like 3 quizzes now. Okay, when you are multiplying like bases, oh dear, we're going to have light issues again. When you're multiplying like bases, you should add the exponents, right? So this would be, for example, if we were looking at x squared times x to the third, we would add 2 plus 3, and that would give us x to the fifth. Okay? If you are dividing like bases, you should subtract the exponents. So that would be, for example, if you had x to the fifth divided by x to the third, that would be 5 minus 3, which is x to the second. When you are taking a power to a power, you multiply the exponents. So for example, if we had x to the fifth squared, that would be 5 times 2, which is 10. When you have a negative exponent, you should take the reciprocal of the base. So for example, if you had x to the negative third, you would flip that and make it x to the positive third. When you have a number or a variable raised to the 0 power, the value of that is going to be 1, right? So if we end up with something like y to the 0, that whole thing goes to 1. If a number is raised to the 1/2 power, that means you take the square root of the base. And so, for example, if we had 25 to the 1/2 power, that's the same thing as the square root of 25, which is, 5. You can't see that. There you go. Okay, so on to some examples now. Given A is 2, B is 3, and C is 1, we want to evaluate each one of these expressions. Okay, so the first expression is 15 minus A times B plus C. Okay, so I'm just going to go in and plug in the numbers I know. So A is 2, B is 3, C is 1. And I'm just going in order of operations here, so I want to make sure that I'm doing anything in the parentheses, then any exponents after that, then any multiplication, then any division, and then addition and subtraction last. Okay, so I start inside here in the parentheses. I add 3 plus 1, that gives me 15 minus 2 times 4. And this is tricky because people always want to subtract this 15 minus 2 first, but I have to do parentheses first, and then I have to do multiplication before I add or subtract. See, addition and subtraction comes last. So this would be 15 minus 8, which is 7. Okay. B says negative 2 ABC. When numbers are written next to each other like this, that means multiplication. So if I plug in here, that would be negative 2 times 2 times 3 times 1. And I'm just doing multiplication from left to right. It's all multiplication. So negative 2 times 2 is negative 4. And negative 4 times 3 is negative 12. And negative 12 times 1 is negative 12. C, if you have not hit pause yet and tried one of these on your own, I recommend doing that now. Okay, so when I plug my variables in, I have 6 times 3 minus 2. And I'm using parentheses here, but of course I could do 6 times 3 minus 2. I tend to plug in with parentheses because that keeps me from having potential sign issues. So 16 times 3, that's 18. Remember, multiplication before subtraction. And then 18 minus 2 is 16. The last one is probably the one that is the hardest. Pretty much guarantee you're going to see it tomorrow. So, it is the quadratic formula, the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And you're plugging in, again, we know what a is, and we know what b is, and we know what c is, okay? So everywhere there's a b, we're going to replace it with 3. Everywhere there's an a, we're going to replace it with 2. Everywhere there's a c, we're going to replace it with 1, okay? This plus or minus tells me that there's actually 2 versions of this, okay? So I'll have one version where I do a plus sign, so that b becomes 3 plus the square root of 3 squared minus 4 times a times c all over 2 times a. But then I actually have to do this again because it's plus or minus. I have to do a minus 1 as well, so it's the exact same formula. The only thing that's different is this minus sign right here. Okay, so let me grab a calculator. I could do this by hand or in my head, right? So this would just be 9 minus 8 underneath the square root. But I do want to show you, it is possible to just type it all into the calculator at once. If I can get the screen to go dark enough, I will show you this. And I'm just going to zoom in here. Okay. So what's going to happen here is I'm going to hit Control Divide. Well, you may not be able to see that. And I'm going to just type everything at once. Okay, so I'm going to type negative 3 plus the square root. I'm going to put b in parentheses minus 4 times a times c all over 2 times 2. That's a 3. And I'm just going to hit enter. Okay, so my first answer here would be negative 1/2. And then I'm just going to scroll up until the whole thing is highlighted, and I'm going to hit enter on it. And I'm just going to backtrack to where this plus sign is, because the only thing that's changing here is that should be a minus, right? So here are my 2 answers. The first one is negative 1/2, and the second one is negative 1. Again, you can absolutely do this without a calculator. You would do 9 minus 8 is 1, square root of 1 is 1, negative 3 plus 1 is negative 2, divided by 4 is negative 1/2. Okay, so it is 100% possible to do this without a calculator. On this side, that would be 9 minus 8 is 1, square root of 1 is 1, negative 3 minus 1 is negative 4, divided by 4 is negative 1. So, of course, do it without a calculator if you feel confident. Okay, so that's that section. That first section, or excuse me, second section is just plugging numbers into variables. So let's move on to the next section. The next section says to simplify. I'm going to flip my paper upside down, so you may see a little upside down work here. Simplify each expression. So my first one just says add your like terms. So 6x plus 1 plus negative 5 minus 4x. So I'm actually just going to add my like terms. I'm going to cut some highlighter here. So 6x gets added to negative 4x. Remember, you got to pull the signs with it. And 1 gets added to negative 5. Okay, so those are the ones that are going to go together. And when I add 6x and negative 4x, that's going to give me 2x. And when I add 1 plus negative 5, that's going to give me negative 4. And I lost total focus there. It's a crazy camera. Okay, and then once you've combined like terms, you're done. That's the answer. Okay, question B. This one, we're subtracting like terms. So we have x squared plus 2x minus 3 minus 4x squared minus 9. This is the one where I said you can just drop the parentheses and change the signs of everything that comes after it. We can also just think about taking away, right? But I'm going to do that method where it's like, okay, let's just distribute this negative and drop the parentheses. So that would be x squared plus 2x minus 3 minus 4x squared minus negative 9. By the way, minus and negative becomes plus, and you can see those two change signs there. And then from there, I can just combine like terms just like in the previous problem. Okay, so I can combine this x squared with this negative 4x squared, and I can combine this negative 3 with this positive 9, and then I've got nothing to combine the 2x with. So x squared, or 1x squared if you prefer, minus 4x squared. 1 minus 4 would be negative 3x squared. Bring down the plus 2x, and then we have negative 3 and positive 9 coming together to make positive 6. Okay, C is going to work a lot like B. So we have 8x plus 3xy minus 2y minus x minus 6xy plus 7y. Okay, and again, I've got a minus sign in front of the parentheses, which means I have to subtract all three. So we think about it like distribute the subtraction sign. That's kind of what we think about. Okay, so we drop the parentheses. Nothing in the first parentheses changes at all. And then we have minus x. We have minus a negative. That becomes plus 6xy. We have minus a positive. That becomes minus 7y. And then I can combine like terms. So let's see what I've got here. I've got an 8x and a negative x. I've got a 3xy and a 6xy. And then I need another highlighter color. I have a negative 2y and a negative 7y. Okay, so 8x minus 1x. Remember, if there's no number written, we can just replace it with a 1. 8 minus 1, that's going to be 7x. And then a positive 3xy and a positive 6xy, that's 3 plus 6 is 9. Remember, when you are adding and subtracting, the exponents don't change at all, just the coefficients. Negative 2y and negative 7y, that gives me negative 9y. Okay, moving on to D. So let's see, there we go. We've got distributive property on D. We have negative 4 times 2x squared minus 6x plus 1. So I know I need distributive property here because I have addition and subtraction inside this parentheses, right? So if I have more than one term in the parentheses, then the negative 4, or whatever's outside, gets multiplied times all the terms. So we have negative 4 times 2x squared. So because there's no variable here, the only thing that's going to change are my coefficients. All of my coefficients are going to get multiplied times negative 4. So negative 4 times 2, that's negative 8x squared. Negative 4 times negative 6, that's positive 24x. Negative 4 times 1, that's negative 4. Again, notice how my x's didn't change at all because all I'm doing is multiplying by a number, not a variable. Okay. All right, moving on to E. Another distributive property question. So E says 2x times 3x cubed minus 2x squared minus 5x. Now, this is one that's been a little confusing for people here. I'm distributing 2x, which means my coefficients change and my variables change, right? So the 2 is going to multiply the 3, the negative 2, and the negative 5, okay? And the x part of this is going to change the x cubed, the x squared, and, well, there's nothing over here for it to go with, so it's just going to tag along. right? So when I distribute, 2 times 3 is 6. And remember, invisible 1, if there's no exponent written, it's a 1. So x to the first times x to the third. Add your exponents because you're multiplying like bases. That gives you x to the fourth. That's just the first term, though. Now we do the same thing to the second term. So 2 times negative 2, that's negative 4. X to the first times x to the second. 1 plus 2, x becomes 3. And then my third term, 2 times negative 5 is negative 10. X to the first times, it's got nothing to multiply by, so it just stays x to the first, or just x. All right, part F. We have a binomial times a binomial, so this is 3x plus 5 times 2x minus 4. Okay, so if this were just the 5, you can't see that. If this were just the 5, then I would distribute just 5. And if this were just the 3x, then I would distribute just the 3x. But because there's 2 terms here, I have to I have to distribute both of these terms to both of these terms. Okay, so I'm actually going to do 4 multiplication products here. So I'll do 3x distributed first, right? So I'm actually going to, let me switch to colored pen. So I'm going to multiply 3x times 2x. 3 times 2 is 6. And then x times x is x squared, right? Because those are both x to the first, so you're going to add the exponents. So that was 3x times 2x gives me 6x squared. And then I'm going to do 3x times negative 4. So 3 times negative 4 is negative 12. X doesn't have anything to multiply by, so it doesn't change. Okay? Then, this is going to end up being a Christmas-looking problem. Got my green marker here. I have to distribute my positive 5. Okay? So my positive 5 times my 2x. 5 times 2 is 10. X doesn't have anything to multiply by, so it doesn't change. And then positive 5 times negative 4, that's negative 20. And you should notice right here in the middle, more often than not, these are going to be like terms and you're going to be able to combine them. So 6x squared doesn't have a like term, but negative 12x and positive 10x, those can go together because as they're both x to the first power. So negative 12 plus 10 is negative 2x to the first, and then bring down the minus 20, and it is simplified. And there's another one of those on G. So G, we have 2x minus 7 times 2x plus 7, right? And so we end up doing the same thing here. Both of these terms have to distribute to both of these terms, okay? So I start with my 2x, and the first thing I'm going to do is distribute my 2x to both of these things. So 2x times 2x is 4x squared. 2 times 2 is 4. X times x is x squared because it's 1 plus 1. And then 2x times 7. So 2 times 7 is 14. X doesn't have anything to multiply by, so it does not change. Then after I distribute my 2x, then I distribute my negative 7. So negative 7 times 2x, that's negative 14x. Negative 2 times negative 7 times 2 is negative 14. X doesn't have anything to multiply by, so it does not change. Okay, then negative 7 times positive 7 is negative 49. After all my distributing is done, then I go through and I want to make sure nothing combines. These are like terms because they're both x to the first power. So negative 14 and positive 14, that adds to 0. So these are actually gone. And I have 4x squared minus 49 as my final answer. Okay. That's it for that section. Then we move on to an exponent section. We move on to the exponent section. We've done so much of this. I kind of hope we have our heads wrapped around it a little better now. So a is 8x to the 5th over 2x to the negative 2nd, x to the 3rd. So notice how these are all like bases. So somehow I have to combine them all. Okay, so the first thing I'm going to do is I'm just going to combine them in the bottom. When I multiply like bases, I add the exponents. Okay, so the first thing I'm going to do is just rewrite that denominator, so numerator isn't changing, as 2x to the negative 2 plus 3, which is just 1. Okay, and then once I do that, I can separate numbers and variables. So I'm going to divide my coefficients, and because these are like bases, I'm going to subtract my exponents. Okay, so 8 divided by 2 is going to be 4. X to the 5 minus 1, which is actually also 4. Okay, part B. We have x to the 6th, y to the 4th, over x to the 9th, y to the 2nd. Nothing in the numerator or denominator can combine, so I'm going to separate my variables. I'm going to divide my x's, which means I'm going to subtract my exponents. I'm going to divide my y's, which means I'm going to subtract my exponents. So it's going to be x to the 6 minus 9 and y to the 4 minus 2. 6 minus 9 is negative 3. 4 minus 2 is 2. Remember, anything with a negative exponent, I actually have to take the reciprocal of and make the exponent positive because I cannot end a problem with a negative exponent. And anything that doesn't have a denominator, remember we got that invisible 1 denominator. And then we can multiply 1 times y squared as y squared, and x times, wow, x to the 3rd times 1 is x to the 3rd. So sorry. Now remember I said you can skip this step. This is what actually happens. But what's going to happen is this. If the exponent's negative, that means I needed to take the reciprocal of it, which means it's going to end up in the bottom of the fraction. That's going to always happen. Okay? So that would be my final answer. C. We have 3ab cubed times negative 5a squared b to the 4th. So this is just multiplication, and I'm multiplying the things that are alike. I'm going to multiply my 3 times my negative 5. I'm going to multiply my a to the 1st times my a to the 2nd, which actually means I'm going to be adding exponents. I'm going to multiply my b to the 3rd times my b to the 4th, which actually means I'm going to be adding exponents. Okay? So 3 times negative 5, that's negative 15. A to the 1st times a to the 2nd, that's going to be a to the 1 plus 2, which is going to be 3. B to the 3 plus 4, which is going to be 7. So this final answer is negative 15, a to the 3rd, b to the 7th. Okay, part C. Oh, we just did C. Part D. We have negative 2, a to the 3rd, b to the 5th cubed. Right, so remember this means that I'm going to cube, cube, cube. So I'm going to take negative 2 and I'm going to cube it. I'm going to take a cubed and I'm going to cube it. I'm going to take b to the 5th and I'm going to cube it. So that means right here I'm going to do negative 2 times negative 2 times negative 2, which is going to be negative 8. Power of a power, when I have an exponent that's being raised to an exponent, that means I'm going to multiply. So that'll be a to the 3 times 3, which is 9. Same thing is going to happen here. I have a power of 5 raised to a power of 3. So that means I'm going to do 5 times 3, which is 15. All right, E. We have, let's see, 3x to the third y squared times 4x to the fifth y to the negative sixth. Okay, so I'm going to do first this outside square. So anytime there's an exponent on the outside of the parentheses, that means it has to come first. Order of operations, exponents before multiply, right? So I'm going to square, square, square. So 3 squared is going to be 3 times 3, which is 9. Power to a power, so this is going to be 3 times 2, x to the sixth. Y has an invisible 1 happening here. I hope I wrote that right. Let me check really quick. Okay, yeah. That's y to the first squared, so 1 times 2 is going to be y squared. So this is the first monomial after it's been squared. Okay. Now I'm going to multiply the things that are alike. I'll multiply 9 times 4. I'll multiply x to the sixth by x to the fifth, which actually means I'm going to be adding exponents. And I'll multiply y to the second by y to the negative sixth, which actually means I'll be adding exponents. So 9 times 4 is 36. X to the sixth times x to the fifth. 6 plus 5 is 11. Y to the 2 plus negative 6, which is negative 4. Remember, this guy, you take the reciprocal of him because it has a negative exponent. So that means 36x to the third, which is positive exponent, stays in the top. Y to the fourth goes to the bottom. F. We have 45a to the fifth, b to the fourth, divided by 9a to the second, b. Remember, if there's no exponent written, there's an invisible 1. And again, I just separate the things that I'm going to divide. So I'll divide numbers, just like normal. I'll divide my a's, which actually means I'll be subtracting my exponents. And I'll divide my b's, which actually means I'll be subtracting my exponents. So 45 divided by 9 is actually going to be 5. A to the 5 minus 2, which will be 3. B to the 4 minus 1, which will be 3. Positive exponents means I can be done. G, we have 4x to the sixth, y to the 10th, over 24x to the 9th, y to the 5th. Again, let's separate our numbers. 4 divided by 24, divide like normal. Divide x's by subtracting exponents. And then divide y's by subtracting exponents. And we end up with 1 over 6, which is 4 over 24, times x to the 6 minus 9, y to the 10 minus 5. 6 minus 9 is negative 3. 10 minus 5 is y to the 5th. 6 is in the bottom of the fraction because it's 1/6. Negative exponent's going to put this whole thing in the bottom of the fraction. Positive exponents means this guy's going to stay in the top of the fraction. Okay? So in the top of the fraction, I have y to the 5th because it had a positive exponent. 6 goes to the bottom of the fraction because it's a denominator in the 1/6. X to the third goes to the bottom of the fraction because it's negative. And that's my final answer. One more in this section, and then I'm going to do a second video for the second part of this. H, we have 3xy to the second times x squared y over 6x squared y. Okay, I really need to multiply before I divide. Okay, so the first thing I'm going to do is I'm going to multiply my 3 times my 8. I'm going to multiply my x to the first times my x to the second, which actually means I'll be adding exponents. I'm going to multiply my y to the second by y to the first, which means I'll be adding exponents again. And I'm going to leave division until after I multiply. So 3 times 8, that's 24. X to the 1 plus 2, which is 3. Y to the 2 plus 1, which is 3. Over 6x squared y. And then I separate again. I divide 24 by 6, just like normal. I divide x's by subtracting the exponents. And then I divide y's by subtracting the exponents. 24 divided by 6 is 4. X to the 3 minus 2, which is 1. Y to the 3 minus 1, which is 2. I do not have to write the 1. Remember, that can be an invisible one. But if you write it, it's fine. Okay, I'm going to stop there because this video is getting a little long, and I will work the second part of this review on a second video.